All right, friends, here we are. This is question number 5 on the 2016 AB International International Exam. And as you can see, no calculator is allowed on this question. So what do we have? We don't even have much here. We have a function f defined by f is 3x squared plus 2x for x less than or equal to 0, and e to the 2x plus 2 for x greater than 0. Okay, we have a piecewise function. We've seen these before. In part A, the question asks, is f continuous at x equals 0? Well, it's been a while since we studied continuity, but in order for a function to be continuous at a point, 3 things have to be looked at. We need to see, is the function defined at that point? We have to see what's the limit as x approaches 0 from the left. We need to find the limit as x approaches 0 from the right. And all 3 of these need to have the exact same value. Well, let's take a look at this. What's f of 0? Based on the way the function is defined, at x equals 0, we're going to use the top half. And so this is 3 times 0 squared plus 2 times 0. That's 0 plus 0. Great. To find the limit as x approaches 0 from the left of f of x, I need to think about this for a second. I'm using values to the left of 0. Those are numbers like -1, -0.1, -0.001. They're all less than or equal to 0. So I need the limit as x approaches 0 from the left of 3x squared plus 2x. As x gets closer and closer and closer to 0, 3 times x squared gets close to 0. 2 times 0 is close to 0, and then 0 plus 0 is 0. Well, that's good. These two are equal. Now let's take the limit as x approaches 0 from the right. These now are values greater than 0, so we're going to use e to the 2x plus 2. And as x gets close to 0, 2 times x is close to 0, and so we get e to the 0 plus 2. E to the 0 is 1, and 1 plus 2 is 3. Now remember earlier I said that we have to check all 3, and they all need to be equal to one another for the function to be continuous. We can see that the limit as x approaches 0 from the left of f of x is not equal to the limit as x approaches 0 from the right of f of x. Therefore, f is not continuous at x equals 0. Okay. So how did they award points? 1 point was awarded for looking at the limit from the left and right of 0. These are called the one-sided limits. And then 1 point was for your conclusion. And so that's it. Not too bad. Probably some places where we're going to make mistakes with notation. And you just need to be really careful and really specific with the way that you write these things up. All right, let's get back to this. I had a little bit of a technical glitch with the previous filming, so we're going to get back into part B. We're asked to find f prime of -2 and f prime of 3. Well, before we can find f prime of -2, we need to find the derivative of the function for the part that contains -2. Since -2 is less than 0, we're going to take the derivative of 3x squared plus 2x, and that derivative is going to be 6x plus 2. Now we plug in -2, and you get 6 times -2 plus 2. That's -12 plus 2, which is -10. To find f prime of 3, again we find f prime of x for the part of the function that contains x equals 3. Since x equals 3 is greater than 0, we're going to take the derivative of e to the 2x, and we get e to the 2x times 2. F prime of 3 then is e to the 6 times 2, or 2e to the 6th. I would hope that both of these are very easy questions for AB students. 1 point for coming up with -10, 1 point for coming up with 2e to the 6th. for a grand total of 2 points. Not too bad. Okay, let's move on. Let's look at part C. In part C, we're asked to explain why f prime of 0 does not exist. Now, an easy way to do this is to remember what do we already know about the function. We know that f is not continuous at x equals 0. And since the function is not continuous at x equals 0, this means that f is not differentiable at x equals 0, and that means that f prime of 0 does not exist. Done. Now, this is only worth 1 point, so your explanation gets you the 1 point. Now, here's what I don't know. I don't know, can you just make the statement f is not continuous at x equals 0, and that implies f prime of 0 does not exist? Or do you have to say f is not continuous, so f is not differentiable, and since f is not differentiable, f prime of 0 doesn't exist? I'm not really sure. When I look at the College Board scoring rubric, what I see is f prime of 0 does not exist because f is not continuous. So that leads me to believe that maybe just this first statement followed up by f prime of 0 doesn't exist is going to be good enough. Either way, this is just a 1 point question. We're going to get in and out, and we're done with this part, so nice job. Now, parts A, B, and C have been relatively straightforward. We've earned a total of 5 points, which means that part D has to be worth 4 points. Now, of course, in the middle of the test, you're going to have no idea how much anything is worth, but I want to tell you that this part D it's going to be pretty significant. Going to be a lot of points possible here. So let's figure it out. Let g be the function given by g of x is the integral from -1 to x of f of t dt. We want to find g of 1. Well, we've been in a situation like this before. To find g of 1, we need the integral from -1 to 1 of f of t dt. Well, if you're going to integrate from -1 to 1, which piece do you use? Do you use 3x squared plus 2x? Do you use e to the 2x plus 2? The answer is you're going to use both of them because both of them are f, but on different intervals. Because the piecewise function is defined so that it changes at x equals 0, I'm going to rewrite this integral as an integral from -1 to 0, f of t dt, plus another integral from 0 to 1 of f of t dt, and that's okay. This says the area from -1 to 0 plus the area from 0 to 1. That is, of course, going to give you the same answer as the area from -1 to 1. Once we do this split, I hope the rest of this is pretty natural. We're going to integrate from -1 to 0, 3x squared plus 2x, or 3t squared plus 2t. As long as you're consistent with your variables, I think you're going to be okay. Plus the integral from 0 to 1 of e to the 2x plus 2. You're going to have to find the integral for each piece separately. The antiderivative of 3x squared, power rule says add 1 to the power, divide by that new power, so it's just 1x cubed, plus, this is 2x to the first, add 1 to the power to get x squared, 2 divided by 2 is 1. We're going to evaluate this function from -1 to 0, plus, now you integrate e to the 2x. The integral of e to the 2x is 1/2 e to the 2x, plus the integral of 2 is 2x, and we evaluate from 0 to 1. When you evaluate, you plug in the top limit first, minus plug in the bottom limit. When I do this with my kids, I always tell them big parentheses minus big parentheses. 0 cubed plus 0 squared minus negative 1 cubed plus negative 1 squared. That's this first integral. Plus the next one, big parentheses minus big parentheses. 1/2 e squared plus 2 times 1 minus 1/2 e to the 0 plus 0. And as ugly as that is a perfectly acceptable answer. I would hope that you would stop here. If you want a little bit of practice with simplification, let's do it. 0 cubed plus 0 squared is 0. So we have the negative of negative 1 cubed is negative 1. Negative 1 squared is 1. Oh, good news. That's 0 as well. We've got plus 1/2 e squared plus 2 minus 1/2 e to the 0. E to the 0 is 1. So minus 1/2. Simplify further. 1/2 e squared plus 3/2. There is no need to simplify. Let's look at where the points come from. 1 point came from splitting your integral into 2 different integrals. They awarded 1 point for each antiderivative, and then 1 point for the evaluation with no simplification needed. So that's 4 points, and that, my friends, is the end of question number 5. Nice job.